Well, here's the second video. This is on chapter 2 of John Polkinghorne, Understanding Quantum Theory. And if you're like me, you can read this chapter and you'd still go, I'm not sure I'm understanding quantum theory. I think he says at some point in here, nobody understands it. That makes me feel a little better. Um, but I think I'm far behind John Polkinghorne on this one. One of the things that amazes me, he says it twice in the chapter. First paragraph, we talking about quantum theory. He says we use it now to think about the behavior of quarks. We had a quark on the board the other day. I don't know if you remember that. There was a quark just sitting there, thanks to what's that guy's name? Is he Zach? I think he's Zach. Is Zach Solly? There was a quark up there. Of course, quarks don't probably just sit around like that. They're on the move. Quarks and gluons, systems that are at least 100 million times smaller than atoms. What? I mean, yes, I just saw Quantum Mania myself, but I gotta read that again. Quarks and gluons are systems that are at least 100 million times smaller than atoms. Okay, my mind is officially blown. I mean, just that weird thing that we can look outward and go out for millions and millions of galaxies, billions, with millions to billions of stars per galaxy in this seemingly never-ending, an unimaginably vast universe. Can you tell I still have a cold? I'm feeling a lot better, but man, it was really rough there for a couple days. And then you can go like in the opposite direction, right? Downward, inward, smaller. Down there to where Ant-Man and the Wasp and her dad Hank Pym and Janet, they all went down there, way down, way down. Well, if you haven't seen the movie, I guess I shouldn't talk about it. I do like Paul Rudd as Ant-Man an awful lot. Bottom of 19, he writes a couple of pages where I really don't understand and says, all that is very straightforward, if surprising, but it is well understood. I wrote out to the side, not by me, not by me. If you just try to do your best to wade through here, what can we say? If we go to page 23, I'm just going to highlight a few things, okay? Page 23. So the question remains, how does it come about that things that are made out of constituents that belong to that or this probabilistic, elusive, indeterminate quantum world become classical measuring apparatus with this amazing... What? I thought I understood that sentence. I thought I knew where he was going to that sentence, and it turned out I didn't. But, I thought he was going to just say, how is it we end up with a world that seems so, solid and predictable, Newtonian, I think is the word for it, objects in motion and all that, and it all, like it's the world, right? Well, turns out not necessarily. It kind of depends on what lens you utilize to look at reality. It's pretty crazy stuff, isn't it? It's crazy stuff. We assume that we're at the level of the real, but in the thought experiment that is the movie Quantum Mania, there are, these intelligent beings living, we'd go like, how could they be that? They're so tiny. But, size is terribly relative, right? Well, we've known that ever since the Men in Black movie, haven't we? With the Orion's belt. You remember that. Surely you saw that movie. Okay. I'm going to just say that there's a lot of craziness going on here. Bottom of 29. Bottom of 29. So we move on. Quoting Polkinghorne. So we move on. The consciousness solution is slightly bizarre. This has to do with the experiment of Schrodinger's cat, which was alluded to in class. It just basically says that at the quantum level, human measurement or perception to a great extent determines outcomes, rather, so that we're not simply observing stuff, we're actually affecting through observation. Yeah, that's just putting it in a nutshell. The problem with anything in a nutshell is it probably belongs there. The consciousness solution is slightly bizarre, but nowhere near as bizarre as the next solution, which is that everything happens. Not just that which not just that the observer determines like a quantum direction for any particular event, but that in fact every possibility happens, which is another movie, Everywhere, All the Time, All at Once, or whatever that is. That everything happens. This is the celebrated, he says, or notorious, according to taste, and for him it's notorious, and he doesn't like it, many worlds interpretation of quantum theory invented by Hugh Everett. And this is a wild idea. I'm going to try to put it in terms that I understand. In every, you'd have to say every millisecond of every event in the universe, one direction seems to be the way things go. I mean, like we have this world right here, but in this theory, in every event, there's another way it could have gone. Things could have gone. Like, I guess that quantum reality could have gone a different direction. Or even at our stage, I could have made a different choice. And this idea is that I do make a different choice in a different world. Or that for every possibility, every possible event, all the other possibilities also happen in some way, somewhere in a world as these possibilities kind of peel off and go in different directions. Wild stuff. And of course, we've had a lot of movies that are kind of predicated on this of recent vintage. I think the Spider-Man Across the Multiverse, I think, was one. And even with the Quantum Mania, if you've seen it, there's a point where Paul Rudd, who is terribly lovable as the Ant-Man, is in what I think it was called a possibility storm. And, it was pretty good, except that there were way too many, what's his name in the movies? I can't remember. Oh, Scott Lang. Too many Scott Langs as Ant-Man. I think I only saw one, Scott Lang as a ice cream guy. And really, for that to be realistic, it would have had to have all kinds of various possible Scott Langs, one in prison, or many in prison, and all these various possibilities of what could have happened at some other point, at every point in his life. These all should have been there, sort of at least, in principle represented. Now, I know there was a whole bunch of those little figures. If you haven't seen the movie, none of this makes a whole lot of sense, does it? It may not make sense even if you've seen the movie. But the idea is that it's part of the problem is we already have this universe that's so vast and so huge with numberless galaxies. What value does it serve to us mentally, I would say, if nothing else, to now speculate that within this vast universe of all the various possibilities in all worlds in over billions of years, that there have been other universes that have spun out from the one that we experience, presumably that we kind of experience and share together. In this idea that, your idea about what constitutes reality has become so, just out of hand. So he does say, because we do not actually understand how quantum theory relates to the everyday world. See, what's being done here is that it's taking what we think happens at the quantum level and then extrapolating it up to, like, the Newtonian physics level. It seems to me, Polkinghorne says, to be slightly overambitious to leapfrog that and apply it to the whole universe. I do end the way he ends this. This is page 33, and he says, top of 33, the moral, I think, is that, if you don't get anything else, get this, is that explanation and understanding are two different things. We can use quantum theory to explain very successfully, well, not we, maybe you can, John Polkinghorne, a great many things about the world in which we live, from superconductivity, I think that has to do with electricity, but I'm not even sure, to subatomic particle physics, like that quantum world down there. But we do not understand quantum theory. Wow. Explanation and understanding are two different things. I think the final moral I would like to draw from this is that however seriously we take science, we should not put it on a pedestal and think, A, that it is different from other forms of human inquiry. Isn't that great? And B, that it knows all the answers, because it is perfectly obvious that it does not. Now, he's not underselling scientific effort, right? He's just saying, look, it's like any other form of human inquiry. Here's where I really stressed interpretation earlier in the semester. I think he'd be okay with that. Moreover, in a remarkable way, science can live without knowing all the answers. We should not be complacent about not understanding, but equally, we can do quite a lot of interesting things without having solved the particular problem of measurement in quantum theory. This, again, is a lesson that has a wider application than in physics alone. I think there was a word missing in that last sentence. Well, it seems that the main point would be, like, even if we went with a many universes idea, which is, I think, virtually inconceivable. Just because it's inconceivable doesn't mean it's not correct, of course. As a Christian and believer that God is the creator of all things, seen and unseen, in the language of the Nicene Creed, it would behoove me to believe that God is the creator of not only this vast universe, but if there were such a thing as a multiverse, and even one so complicated as that in every second, which is just ridiculous, in every moment, in every spot in the whole universe at the quantum level, a new possibility branches out into a whole nother universe. I would make it fit. I would say that just is a testimony to both God's vast creativity and God's invitation to allow possibilities to unfold throughout creation. It does seem like a rather science fiction-y way to think about reality, but interesting. All right, so this covers, last Thursday's class, and this Tuesday we're moving on to chapters 3 and 4, which does not mean you cannot raise a question about any of this. You can, but I did want to kind of go over those first two chapters in this video way. I hope there was some little bit of help in it all. Thank you.